So thank you very much. And today we'll be talking again about the first or the original SPAAM community project, which is called Ancient AMDirT. But we'll be splitting this talk into two parts. One is something that will be relatively familiar with people who've been around for a long time. And the second half from Maxime will be about the new exciting toys to play with for our community. So for those who are brand new maybe to SPAAM, who've not been around or not familiar with the Ancient AMDirT project, this project came out of my frustration when I was tasked to make a count of how many ancient metagenomic samples existed like 5 or 6 years ago, 4 years ago. And obviously that was really difficult because obviously the people who asked me for this for me wanted to know let's say dental calculus or versus bone versus paleofeces or whatever. And trying to trawl through all of the literature to find this information was absolutely horrible because you had to go through things like supplementary information tables, supplementary text, maybe a GitHub repository, maybe the ENA repository, maybe the paper itself, the main text, and that took a very long time, very tedious, and I hated it. Particularly when I had to do this for hundreds or thousands of samples. And so this motivated the idea of what would life be if there's one master table that existed which had all of the information that you would need to when you want to look up ancient metagenomic samples that have been published already. So with all the information that you also would need if you want to reanalyze it, for example, or track, the field over time. And this is where Ancient AMDirT came in. At its core, what it is a set of TSV files, so separated value files, which has all of the metadata that you would need to find samples. Sorry. I can't see now. To basically find the samples that you'd want if you want to include them in your study as comparative metadata or something like that. But critically, it's not just gathering this information. We wanted to make sure, A, that it was easy to filter and play with. And so Ancient AMDirT is standardized metadata. So each column has a fixed list or a fixed pattern that it must follow. So for example, latitude and longitude must be numeric, so not the sort of time, minute format. For example, then we have a fixed list of sites, there's your country names, so you can only pick ones. You don't have Spain, España, Español, or all the weird typos that you might get. And also, like I said, me trawling through all of this myself would take way too long, so it's also community curated. So everybody, particularly in SPAAM, can come along and basically contribute to it and help it to maintain this and sort of help each other over the long run. And then, too long didn't read is that it's not just sample metadata that we now have, we've now extended to library metadata. So as of version or release 23.3, so that was a couple months ago, and actually we have another release coming end of this month, we have added more than 2,000 ancient metagenome libraries. So this is like microbiomes, like oral microbiomes or paleofeces microbiomes, more than 2,000 microgenome libraries, there's pathogens, and then also more than 600 environmental libraries. And I also made this little nifty animation here, which shows just how much sort of the amount of data we're piling up over time as we basically add more and more information to the rich messaging data. You might be wondering, why do we care about library metadata? Well, there's a range of things, and again, we try to make sure that ancient metagenomics doesn't get too big and too unwieldy. So we try to keep it to the metadata that is really important that you need to have when you want to reanalyze data. So the information stored in the library level metadata tables are things like the library name, obviously, but also strand type. So is it single-stranded, double-stranded? Because if you have single-stranded, you might have very, very short reads, which that may influence how you're going to process the data. Library polymerase and library treatment, both of these will influence whether you have damage or not. So that's obviously critically important for validation, but also in downstream analysis when you need to make sure you don't incorporate sort of fake mutations, or how do I call it. If you're working on microbiome stuff and you want to remove contamination using certain models, you need to have library concentration to compare against blanks. So this information is there for the microbiome table. Then things like instrument model, so do you have the 2-color or 4-color chemistry for Illumina sequences, because this may influence whether you do poly-G trimming. Then things like library layouts or library strategy may influence whether you can do de novo assembly on that particular library. And it's just not just about the library, you also have a little bit of information about the FASTQ files. So we list the read count, so is there enough data, let's say, for example, for assembly, de novo assembly? Then was the whole shotgun metagenome uploaded, or is it just targeted capture data? Then also download links, MD5 checksums, making sure that the download is correct, and also how much is all this data going to take up? Because as I'm sure you know, metagenomics is very hungry beast when it comes to memory. And so all of this information is in the same basically schema, the same format that you saw with the sample metadata. So all of that should be pretty familiar to you if you've come across this before. But like I said, it's a community-curated project, and this has been, again, a huge effort of more than 4,000 libraries that we had to basically scrape through, clean up, put in the right format, and so on. So I want to say thank you very, very, very much for all the people who contributed to this phase of the project. And that leads us on to Maxime.
So, until now, when you were adding data to ancient metagenomics, you opened a pull request, and probably you realized that there was a little bot running in the background checking that the data or the metadata you entered were matching the different criteria that we implemented, the one that James talked about just before. And that was kind of the extent of the toolkit that we had. But we realized that it could do a lot more, and that's why we decided to develop it further into what became now AMDirT, the ancient metagenomics toolkit. So what was doing the checks before was ancient metagenomic check, a very mouthful name for a tool, if you ask me, so that's why we renamed it. And also because we extended the functionality that we're going to talk about just after. So what's new? If you go on the GitHub, the link will come just after. What is visibly new is obviously the name, so the name change. There is a new command line interface. There is new documentation and tutorials, and there are also the 3 extra new or 4, depending on how you count them, functionalities that we're going to talk just after. So yeah, the name, the functionality. So, and under the hood, what's not really visible, it's almost a complete rewrite of the first version of the tool. So we kept one part, the validation part, but all the rest is completely new, and the general architecture of the software was completely changed and improved. So the result of 2 hackathons and many more contributors, some of them with pictures online. I added them just below. And 320 comments. So where to start? If you want to learn more about AMDirT, this is the homepage on GitHub, and there's also the documentation. You can install with pip because it's all written in Python, or install it with Conda. It's now also in via Conda. And this is, if you launch it, command line, that's where you would be created with. So you can scroll here now. You can see the difference. Come on. Right. We can see the different subcommands: autofill, convert, merge, validate, and viewer. So what we kept and what we improved is what was the sole functionality of the tool before, the ancient metagenomic check, which is now called AMDirT validate. What we've added is now querying directly ENA for checking that the accession numbers are valid and that the accession numbers of the libraries are belonging to the project. And it's now also doing it in a smarter way. It's only checking for newly added entries, not checking the whole table at once. Otherwise, I think ENA would be mad at us if we do too much querying every time there is someone that makes a modification on ancient metagenomics there. And then there were a variety of bug fixes that I didn't list here, but that was also quite important for making this tool work. Probably the most exciting new addition is this so-called AMDirT viewer, which you can launch on the command line. And this is what you would get. This is a screenshot, but more excitingly, you can also view it directly in your browser. So if you just go on this link, you will be greeted by the online version of this tool. And it's using very, very new technology called WebAssembly. So it's basically running the tool directly in your browser without the server. So that's why it's trying to load all the packages at first. So this is what the tool looks like. You can basically use it to visualize all the sample level metadata in ancient metagenome DIR. And then based on this sample level metadata, for example, in the latest release, we would like to see the ancient metagenome host associated, and we're going to check just 10 rows to make it one. And you can see all the sample level metadata of this table, 10 rows at a time. We have a lot of samples. And you can then filter, for example, by latitude. So we would get everything that is in the north hemisphere. So 0. And then we can select the samples that we're interested in. For example, the samples from a study, 2 of these samples, and then we would go down, scroll down, click validate selection, and then this will basically prepare for us the library table associated with this table, but also the curl download script to download this sample, and we see that it will be approximately 6 gigabytes of data, and even more interestingly, directly the configuration file to run a variety of more or less standardized pipeline using ancient DNA metagenomics. So eager for mapping, NF-Combat for assembly, tax profiler for doing taxonomic profiling, ancient AMETA to do similar things. And also it gives you the citations in BibTeX format, so that at the end, when you're writing your paper with all the amazing findings that you have made on these samples, you can properly cite the authors of the original article. So let's see. Yes. So that's all in your browser. No need to install anything. You can just go here. And so that was ancient metagenome viewer. But if you're more familiar with the command line, or if you want to do more things, more filtering manually, and you're good with pandas or with tidyverse in R or whatever other way of filtering, you can also do the filtering manually. And then this convert is basically doing the same thing. It will prepare the configuration file for all of the different pipeline, the BibTeX citation entries for citing the different articles that you reuse the data from, what else is it creating? That's it. The download script also for downloading all of these samples. So it's the manual, the command line interface to view. Another very exciting new tool is AMDirT autofill. If for some of you already contributed new metadata to ancient metagenome DIR, you probably realize that it's kind of a tedious process. You have to go from the publication, identify the ENA project section number, then go on ENA, look at the metadata at the library level, copy paste them in the ancient metagenome DIR master table. It's kind of a tedious process. So here we've automated it. You just give it an accession number. It can be a project, sample, or library accession number. And it's going to pre-fill the tables for you. So I think I put the link to the tutorial. So we're going to have a look at the tutorial and the documentation. So here, for example, I was actually adding a new article, the data that were published from the article with the project accession number PRGB, this one. And this is what I was doing. This was an actual pull request. Now these data are actually integrated in Ancient Metagenomic here. And this is what would happen. It would create a libraries in a sample table. Here we can see the first few lines of this table. And perform a bunch of checks to make sure that they're good. And then with the next command, the AMDirT merge command, we could then integrate this new autofill data to the master table. So it's not autofilling everything, it's not filling everything up. There are some metadata that unfortunately you still have to look up in the paper because they are not uploaded on ENA. And it also gives you a warning message because some of the metadata that are reported on ENA, especially on the sample level, are not always correct. But it will pre-fill a lot of things already for you, and so I think it will make it an overall much better experience adding new metadata to Ancient Metagenomic here. You don't have to do as much copy pasting, as much looking in ENA as before. That's AMDirT, autofill and merge. So together, since the last release of AMDirT, or previously Ancient Metagenomic Check, we solved 71 issues, merged 45 pull requests, and added almost 320 commits. That's quite a nice achievement. So I just wanted to thank all the contributors and the SPAAM community. I spent way too much time to adjust the settings for making this work loud. And stay tuned for the soon-to-come paper. You saw the author list at the beginning also. And I hope to see many of you in Tartu for the SPAAM meeting before ITBA. And remember that Ancient Metagenomic here is a community project. So yeah, we need you to keep the DIR up to date. And hopefully with the new developments of AMDirT, this now made it much easier. So yeah, thank you very much.
Thank you so much, James and Maxime, for this amazing presentation and for what you're doing. And if someone has some questions, now we have a bit of time to answer them.
I have a little question. Can you hear me?
Yes.
Yes. What is ENA and ISRA, and do you have information from other platforms or something like that?
So, so if you upload on SRA or ENA, they're all mirror between each other. Also with the Japanese platform, yeah, they're all mirrored between each other. So we can. It doesn't matter if we query ENA or SRA. The information is everywhere the same. If you upload, or if people have uploaded the data to more exotic platforms, but there are not so many of them left, then unfortunately we can't really get the metadata. Do you have any statistics actually of how many of the Ancient Metagenomic libraries are?
It's very few. Yeah. Off the top of my head, there's one study that uploaded to a FTP server, and that was one sample, and I think there's 1 or 2 studies uploaded to Picture.
Yeah,
that's it. It's like a handful of samples.
And so just by looking at ENA, we cover almost all of the libraries that are available for Ancient Metagenomics.
Okay, thank you.
I have a question on the autofill tool, because I didn't get specifically when is the moment in which you use it, so yeah, this.
So you would use autofill when you're trying to add new metadata. So to basically a new article was published. Ideally, there was already an issue open on ancient metagenome here, and someone has to add the metadata for the different sample and library from the paper and ENA into ancient metagenome here.
Okay.
And so a lot of these metadata are already available in a standardized format, but on ENA. And what you would need to do, or what you need to manually before, is basically go on the ENA, look for this metadata, and copy them into the ancient metagenome table. Now with this autofill tool, you just give it the project or sample accession number, and it will automatically retrieve the metadata from ENA and put them in a table that matches the format on ancient metagenome here. And then you still have to enter manually the rest of the metadata that could not be retrieved from ENA. Check that the automatically filled metadata are correct, because it can happen that the authors themselves, when they uploaded their data to ENA, they screwed up a bit. Yeah. And then you can use the merge command to integrate it directly to ancient metagenome here, master table.
Okay, thank you.
A link to this question that Bianca did, is there like a limit to how many samples you can use the autofill for, or just?
There is no limits unless you use it maybe very, very heavily, and then the ENA is starting to think that someone is trying to hack their server. I don't think there is a limit. The limit is also that you should still check that the metadata that are entered are correct. So if you contribute hundreds or thousands of samples at a time, it would be harder to check, also to review after. So it's better to do it maybe study per study, or James is trying to do something.
Yeah. So sort of linking the two questions together and what Maxime just said. If you're not familiar with ancient metagenome data, the way the workflow works is we make issues for each publication on GitHub, and there we can talk about, is it relevant to adding, so making sure it is shotgun and not like a 16x amplicon thing. Then one of the contributors, one of you who is listening right now, would basically pick up one of those and then basically update the table to include this new information. And then it goes through a validation process. So the first process is the computer-generated check with validate, and then afterwards there would be a review by a person. So if you had, like Maxime said, like a study with 10,000 samples, that would be very, very fine for the computer, but very difficult for the human itself.
And autofill is basically coming here. It's replacing. Let's say we keep the head of the person, and then the body, we replace it with autofill. So part of the metadata are automatically retrieved. Yes, but keep the head, because you need to check them.
And that's something that you'll see in the paper when it comes out, as we have the section where we talk about a lot of the common problems we, as the contributors, are finding. So, for example, in the ENA upload, let's say they sequence on an XSeq 500, but you read the paper itself and it says, oh, they sequence on a HiSeq 4000, which has quite a lot of different information, like how you process this stuff. And that can be quite frustrating when you then have to manually go check the FASTQ files and you recover that information yourself. So that's why this human curation by the community is very, very important, because humans make mistakes, unfortunately more often than you'd expect, but that's why.
For example, for the tutorial on autofill, there was a problem with the DNA polymerase. So I actually ended up calling Yates for looking at which polymerase they used, because the one that they reported in the paper didn't exist anywhere. So yeah, the metadata have to come from somewhere, and if at the source they are not correct, unfortunately, there is not so much automation that you need to do. But I would say let's be optimistic, and I would argue also realistic. In the majority of the cases, it should be fine.
Yeah.
But you will always have the exception that will take a bit more time than time.
And that's another good example of the QIAGEN thing, why the project is here. So people were submitting kits, and the kits are not listed what they're doing, so you don't actually know what's happening to the DNA. You don't know, is the damage being removed? Is it doing some weird thing and having additional adapters, unlike non-standard adapters which don't move? And sort of by curating this information, that's how we can actually clean this up and make sure it's easy for everyone else to reuse your data.
I have another question, if possible. Speaking always about metadata, you said that there is also in the metadata the library concentration. Is there also a way to know how that was calculated with, or no, in the metadata sheet, let's say?
So for each table we have like guidelines of exactly what should go in there. And for that one, I have specified one way that I knew that I had done when I used to be in the lab a very long time ago. So it's the nanograms per microliter, I think. No, copies per microliter. Do you remember?
In Pandora, it's copies per microliter.
Copies per microliter, thank you very much. But
in Pandora, it's copies in total. So it's copies in 50.
I think, exactly, but I normalize it down to the liter. Okay. Anyway, but with the Minas project, if you don't know about that, which is the next project coming from SPAAM, where we're trying to come up with a metadata template which you would upload with data already. So not try and fix it afterwards, but try and make sure everything is consistent beforehand. We've proposed that column, but already there we started getting some discussions because people are recording that and measuring that library concentration in different ways.
Yeah,
exactly. Which is probably why your question's coming up. So this is something that, as a community, not just in SPAAM, but ancient DNA in general, the field, we need to sort of talk about and ideally come up with one sort of, or as few sort of different ways of reporting that as possible.
I don't know if that would be possible because it depends on what your lab has instrument-wise, and that's not normalizable.
Exactly, that's the problem there. I'm hoping we can sort of restrict it to the fewest ways of recording it, but that covers as many people as possible. But we'll see how that goes. Maybe we have to drop it entirely.
So also with different instruments, like at least knowing what was the instrument used, or do you think that that's not possible?
That is possible. People can write that down. I think the value itself is more the issue. Is it like nanograms per microliter? Is it copies per microliter? There's a bunch of others with people reporting. That should all be consistent between the machines, I would hope. But we would have, again...
Except that we know they're not.
Except we know they're not. We're going to ignore that conveniently and hope it's a rough estimation, which normally is what, at least, tools like Decode, which is what we use. It just needs to be rough. It doesn't mean you're actually precise. So that's what we're aiming for there.
Okay, thanks. Don't know if someone has other questions. Okay. Miriam Bravo says, thanks for the talk. Are these tools open to improvement or suggestions from the community in case anyone would like to contribute?
Very, very much. It's even more than welcome. So as I was saying, it's the result of 2 hackathons and contribution by many different people. You can put the slide. My work lab, I'm so proud of it. Here. So yeah, it's very, very welcome, and I think it's also like a work in progress. There are still issues open because there are new features that are requested.
I made one in the middle of the talk.
Yeah. Okay. So yeah, very, very much welcome to contribute.
And another nice thing about the place we're publishing a paper in is that it allows actual versioning of publications. So you can actually update publications and have version 2, 3, 4 over time. Or a lot of particularly bioinformatics people do, or basically each major version of each tool, they'll actually publish a new version of the publication. So it always points back to the original DOI, so you get all the citations, but it means you can always have a paper pointing to the latest and greatest about that particular tool, rather than something that's, I don't know, 10 years old.
And actually, the more the better, because if you look at the work lab, it's actually just 7 names that repeat all the way. So I hope that for the next time I'll make it work loud, I don't have to set the option on repeat, and we can just add the names of all the people that fill up the whole screen.
Okay, so I also have a question, looking more to the general use of SPAAM and the database and ancient metagenome DIR, how do you see this project to evolve in the years? How is going to be maintained? How is, because I mean now we have more than 2,000 genomes only for one of the section of the ancient metagenome DIR, but it's expected this number to go over the next maybe 5 years. So how do you plan to continue forever maintaining this?
So for ancient metagenome DIR, actually I want it to die eventually. I would like actually that this would be replaced by the ENA. So with the Minas project with these metadata sheets, at that point you can just search the ENA and get the same information. But in the meantime, again, it's up to the community basically. So we have these issues, we have the documentation, we occasionally have training and things like this to get people involved. And if you're ever interested if you want to get involved and help out, please just let us know on the Slack channel and we can run another training session. But I hope, I designed at least the ancient metagenome section and SPAAM in general is to basically divide and conquer. So if everyone takes a little bit, it's much easier on your time. You don't have to do 200 papers, just one, because there's 200 people doing one each. That should make it easier for people to sort of go through this. Another way is trying to encourage people that when you do get your publication done, when it's published, you yourself go and actually add a pull request to add the information. To make it even easier, you could even use the tables that we have in ancient metagenome DIR as your supplementary information table for your publication. And see, it's just a copy paste and it's straight in. So it's also a good way of doing it. And
so if you look at how the metagenomics modern metagenomics has developed, now there is this how it's called, this Magnify database that didn't exist a few years ago, but still I think most of you know this project Creative Metagenomics that kind of gave us the inspiration also for ancient metagenome DIR, and their project is still going on because people use it because it's very nice. And one way also to develop maybe ancient metagenome DIR would also be to provide these taxonomic profiles with the pipeline, for example, such as Tax Profiler, which has already input sheets prepared by AMDirT. So yeah, there is before ENA, it would be cool if ENA would basically take over right now and we don't have to do any of these. That would be much easier for everyone. But I think before this actually becomes a dream come true, I think there is still a lot of potential to develop ancient metagenome DIR and AMDirT further.
And that's a good point. The other thing I hope is by making it easier for people to find this data, public data, they can play with it a lot more. They come up with their own tooling, they can open their own projects, their own spin-offs and extensions of it to make it just usable and useful and to keep it going. So I think the more stuff that comes out of it, and the stuff using it, the longer it will stay around because people consider it to be quite important.
I just reviewed the paper today where they use actually ancient metagenome DIR, so I was like, yes. came back. We closed the circle.
Okay, Miriam says, as a comment, it would be valuable to consider incorporating the metadata information recovered from the ancient metagenome DIR before finalizing the paper. This is particularly important as certain information may have been challenging to retrieve. Any paper?
Exactly. So, like I said before, if you use the ancient metagenome DIR tables as the template for your papers, then that information will be there and for you later on. And if there is any other critical information you think is missing from ancient metagenome DIR that should be added, you can also propose that, and we can go back and update that. It's hard, but again, we have this community sort of momentum, I think, with the metadata-thons when people get bored of their normal work and the day off. We can also extend things in that manner. So, contribute to ancient metagenome DIR that way, but also if you have particular things like Miriam says that we should be adding before we upload the data with the paper, also join the MENAS project, because that will be where the big bulk of that will be coming from. And just as a slight extension of the last sentence from Miriam's comment is that, some of this information can be really, really difficult to retrieve. So in one example, which is in the paper, there is a study which basically cited another study for the library construction. That library construction, that first study said, we used a protocol from this study. You go to that study, and that actually had an experiment, like experimental method section where they tested 4 different protocols. And the second publication didn't actually mention which of those 4 they used, and so there's no way of knowing in the first one whether there's any modifications or which protocol the original one was used. And also, given that the field in which the third publication was working was completely different from the one that first publication it makes it even more difficult to work out what is actually there or not. So, by putting the very, very critical information, the very basic information, like the stuff like slight modifications to, I don't know, concentrations or volumes, that's maybe not so important. The stuff like the polymerase that's used, so is it double-stranded or single-stranded, that's really critical, and that is where it should go into sort of a table in supplements like here. And not hidden away in some text in the middle of nowhere. And particularly when you start writing 500-page supplements.
Any other question? If not, well, I just wanted to say, I don't know if you have realized, but there was a new logo of SPAAMtisch that kindly James did. I don't know, James, if you want to, if you have it already on your screen or something that you can
keep rambling for 30 seconds while I find it.
Yeah.
Sharon? Yeah.
Yay! Yes, so it's now in the official page of, in the SPAAMtisch section of the website, and it's, I think I did a tweet about it as well some time ago in one of our huge tweet threads. So there you go. Thank you, James.
So we need to make the logo a reality in Farco then.
Yes.
We can print it.
I agree. Okay, I will stop the recording and